So now we're going to use that information to kind of help us with this. Use synthetic division and the remainder theorem to find the exact values of all the roots of the polynomial below. We're going to need to use our calculator though to help us a little bit because there are ways of factoring this. There is a method. I could use a group and factor method on this to essentially factor this into a quadratic and a linear. Okay, um, which will make my life a whole lot easier as far as being able to determine where the zeros would be and things like that. But here, I'm just going to assume that we don't know those other methods or we don't remember them because, again, these are kind of things that tend to come towards the end of an Algebra 2 course or make up like a small part of a high school level pre-calculus course that aren't spent a whole lot of time on because it gets a lot easier. Without using a calculator, it gets a lot easier if you're trying not to use a calculator if you have calculus and some of its concepts under your belt whenever you're trying to do it. But for here, what you're seeing here is that I graphed this on a calculator. So I'm showing you that basically I'm putting in y equals x to the third power plus 2x squared minus 10x minus 20. And on a window on my calculator, I set the minimum of x to be negative 5, the maximum to be 5, the y minimum to be negative 20, the y max to be 10, and the y scale to be 2. I'm looking to see, okay, well here, if I'm looking for the roots, I'm looking to see where this graph essentially crosses the x-axis. Because remember, a root would mean that the f of x, or in this case y, would become 0. And if I go to my calculator, I can see by looking at the graph here, or by using the calculation function on my calculator. And I show some slides where that's actually used in a little bit more detail, so I'll show you that in a moment. I could use that to figure out that I do have x equals negative 2, or x is going to equal plus or minus 3.162277766 dot 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 dot. So x equals negative 2. Negative 2 is an integer, so it's very rational. I can come up with an exact answer. So rational numbers are easy to find graphically. Okay. Irrational ones get to be a little bit more difficult because I'm not going to necessarily know it's 3.162277766. So I want to get the exact answers, and you're often going to be asked, and as it clearly says up here, and always keep a mind out for this, you're going to be often asked to do the exact value. 3.162277766 is an irrational number. If you write it as a decimal, you'll never get it to be exact because you have to round off somewhere. An irrational number is a number that can't be written as a fraction. That's what the whole rational comes from. It can't be written as a fraction if my decimals don't terminate, nor do they have any kind of repeating pattern. And this certainly is showing that. People think, well, it's a pattern, 227766. Well, does it repeat? Well, we haven't gone far enough, it's hard to tell. So I want to find an exact value. Either it would come out to be a fraction if it is in fact rational, or it's going to come up with some sort of radical expression with a square root symbol usually. If it isn't. So I do know that negative 2, however, is a root, which means that x plus 2 is a factor.